It's AP, sorry. Any questions from the homework last night, the 3-1 and 3-2? Anything in there that didn't make sense to you? You were able to go back and check them on the answer keys? Okay, you checked your work? All right. Okay, so let's go ahead and get started with this guy. Display settings, duplicate. There we go. All right, so we are doing something called percent composition. So for example, if we had a bracelet and that bracelet had 20 beads in it, we could see how many of each color comprised this. Every day it does that. Okay, you could see how many of each color bead it comprised. You could count all those up. Then you could add all those values together, and that would tell you how many total beads it was. They did tell us 20 in the beginning. If they don't tell you, then you just add them up and get the bottom number. And then you can take the top number, so however many beads you have, so 9 divided by 20, and that would give you the percentage. Does that make sense? That is the whole theme for this, part over the whole. That's the theme for today. That's going to be the theme anytime you do a percent. It's part over the whole. Okay. All right. So like I said, theme is part over the whole. Regardless of the amount, a compound is always comprised of the same elements in the same proportions, because a compound has, remember yesterday we talked about the things that made a compound a compound. 1, they're composed of different elements. 2, they're chemically combined. And 3, they're in set ratios. So you can look at the composition of that and those percentages, and if they're equal to whatever you're looking at and comparing, then it's the same thing. All right, so how do we do this? Percent mass is the mass of an element divided by the mass of the compound times 100. So here we have 78% of a compound. Do you guys have these notes?
Yes.
Okay. You're starting to scare me here for a second. 78% of the sample is unknown. We know that 12.4 grams is hydrogen. They want to know what the percent of the hydrogen is. So if we take our part and we divide it by the whole, 78.0 grams times 100, that's going to give us our percent hydrogen. So I ended up with 15, and I'm just going to round it to the tenths place, and I'm okay for you guys doing that. It will be 15.9. And make sure you put your percent sign and what element it is. So these are essentially your units for percent. The percent sign and what item it is that you're doing the percent of. Okay? Easy enough?
Yes.
Questions on that one? You doing okay, Haley? All right. Well, let me move on to the next slide. Yes. Okay. So we can also do this if we're given a chemical formula. All right. So the way we do this is we write an inventory down of the elements that are present. This is an L for chlorine. A lot of people see that as an I, like a capital I. It's not. So they think it's carbon and iodine. It's not. This is an L. Can you see the difference in an L versus an I? If it was an I, it would have bars across. And this has like that tick. I try to use the same font all the time so that there's a difference between the L's and the I's. Some fonts, they look identical. So I try to use a font that distinguishes that. So this is sodium chloride. So I write down an inventory of the elements that are in the compound, and then I count how many I've got. There are subscripts that appear down here if we have more than one. So neither one of these have subscripts, so that means that we have one of each of these. And then we're going to multiply. So get that written down, and then I'll tell you what we're going to multiply by. So you are going to find on your periodic table in the first column, 3 things down, Na. That is the symbol for sodium. Okay. Down at the bottom, and it should have an 11 here. And then down at the bottom, it's going to be 22.9. Anybody going to help me out? Nobody's going to help me.
22.990.
990. Okay. All right. So for masses in here, we round to the 10th place. So we want to round these values to the 10th place. So what would this guy round to if I was going to that 10th place?
23.
23.0. Okay. So I'm going to multiply this by 23.0. My chlorine then is straight over in the same row, almost to the end, is where chlorine is. And that is number 17. And its mass on here is 35.453. So what would that round to for the 10th place? 35.5. Good. Okay. So I'm going to go 35.5. Okay. So those are my 2 parts now. All right. I am then going to add them together to get my whole. So there is my whole. I added these 2 things together to get my whole. Everybody up with me so far? Now we're going to do part divided by whole. So I'm going to do 23 divided by 58.5 times 100 equals, and down here I would do 35.5 divided by 58.5 times 100 equals. Okay, see if you can come up with those values on your calculator. I ended up with 39.3, and that's going to be percent. And then I can go back over here at the beginning. It'll tell me what element it was. So percent Na. And then the next one I ended up with 60.7, and that's percent chlorine. These values, when you're done, should add up to be what? 100. Now, occasionally you'll end up with 99.9. Occasionally you'll end up with 100.1. But beyond that, you probably should check your math. Okay? But it's a quick, easy check to make sure that you did it right. That makes sense? So you can kind of look at it, add them up, and if they don't add up to be 100, go back and look. All right, let's try another one. All right. So now we're going to write our inventory down. I have calcium, I have chlorine, and I have oxygen. We got to talk about parentheses. All right, how many calcium do I have? 1. Okay, there's no subscript down here. I have 1 of those. All right, now we got to talk parentheses. What do you do in math when you want to get stuff out of parentheses? Distribute. How do you distribute? Multiply. So I'm going to multiply the subscript here by whatever this subscript is here. Okay, so what is this subscript here? It's not written out. It's assumed to be
0.
no,
Or
1.
Sorry.
If it was 0, they don't write the element down. Okay, so 2 times 1 is 2. How many oxygens would I have then? 6, because 2 times 3 is 6. Go back to your periodic table and see if you can figure out what you're going to multiply each of these by. Chlorine, you can look at the previous problem. It's already... You can grab that from the previous, as far as the mass. Not the multiplication, not the answer, but the mass. Some of these you'll start to memorize through the year. You don't have to. You'll always have that periodic table with you for a test, or my version of it. If you don't have your annotations and cheat sheets. All right. So for calcium, you should have gotten 40.1. Chlorine is 35.5. And oxygen, you should have 16.0. Anybody not able to get those values for their masses? Good? All right. So I'm going to multiply across. I'm going to multiply across. And I've got all my parts now. What do we do with our parts? Add them up to get our whole. So I'm going to add all of those things up to get my whole. And I ended up with 207.1. I'm going to take then each of my parts and divide by my whole. .4. That's percent calcium. And 34.3. And that is percent chlorine. And 46.4. And that is percent oxygen. Good?
Yes.
Work out for you? Okay. We do this several times a year, so you need to be comfortable with how to do this. We do a lot of percentages throughout the year, so you need to be really comfortable with how to do percentages as well. Percentages are just find the part, divide by the whole, multiply by 100. It's just a real commonplace thing that we end up doing. All right, anybody need more time on this problem? Doing okay with it? Is it making sense?
Yes.
Okay. All right, I do. We have 3.5 grams of X reacting with 10.5 grams of Y. We're forming compound XY. What is the percent mass of X and the percent mass of Y? So what do I need to do first here? Help me along.
You gotta add X and Y.
Okay, I got to add X and Y to get my whole. Okay. I'm going to add those two together, and then I'm going to divide each item by that. So I'm going to do 3.5 grams of X divided by the whole, which would be how much?
14.
14. Oops. Okay. Okay, that's just going to have to stay there. I was trying to get rid of that little dot there, but I can't. So 14.0 times 100, and that's going to give me my part. So 3.5 divided by 14 is 25%. Now, if I don't want to go ahead and write all of this stuff out again, how could I figure out y without, since there's only two parts? Right, I could subtract from 100, right? Since there's two components, that means the other one must be the remainder. So if I take this minus 100, or from 100, then 75% would end up being y. And then you don't have to do all the writing out and such. Does that make sense? How that works? Okay. Let's do, we got another I do here. So let's see if we can do this together. I've got my inventory written down. I have my 6 carbons, my 12 hydrogens, and my 6 oxygens. See if you can find those masses on the periodic table and get them rounded to the 10th place. I miss my old whiteboard where I could toggle between different colors easily. How'd you do? Still working on it. Let's see. All right, everybody cool with this one? Ready for the, what's wrong, Ivy? You good? Making sense? Okay. All right, ready for the next one? Oh, this one's got parentheses. Got our aluminum, chromium, and our oxygen. So I have how many aluminums? 2. The parentheses doesn't apply to that one. How many chromiums do I have? 6. And how many oxygens? 21. Yeah, that's crazy. I gotta look that one up. This one I have memorized. All right, see if you can go from there. All right. You okay on that one? Am I going too fast?
Yes.
Well, when you get done with that one, you got at least one we do. So see if you can go down and start working on those.
Okay.
I only got 7.7.
For aluminum, 7.7. Maybe I can't read. Oh, yep, it is 7.7. That's an easy fix. There we go. Better?
Yes.
Call me on these things because I'm probably wrong, y'all. I make mistakes all the time.
I didn't even notice. I was just checking my answers. I'm too tired.
Yep.
So,
All right, y'all still need this page up? It's good? Okay, so here's our we do. We got 2 we do's to do. Let's see if you can come up with the answers to the we do's. All right, let's get a couple answers up here for you. I had 1 over 20 and 19 over 20. Did you remember to add these to get your whole? Good. Okay. So this is going to be times 100. So I think this is 5%. And that would be 5% hydrogen. And this would then be 95% fluorine. How'd you do on that one? How did I do on that one? Hopefully okay. I did the math in my mind. I hope I'm solid on that one. I can handle that one.
good.
All right, see if you can do the next one. This one involves a little bit of distribution. How we do?
2, 4.
Good. Anything you don't know where I got a number from, you don't know how I got a calculation, any of that stuff. Everybody's good with it? Good. All right, so you got a little bit of time to work on your homework. About 15 minutes, you should be able to knock it out in that amount of time, and then you don't have to worry about, yep.
I got yesterday's homework done.
Okay.